All right, ready to dive in. Today we're tackling loops. And honestly, when I first saw the title, I thought we were going to be talking about those catchy pop songs that get stuck in your head.
Well, those are definitely loops, but we're diving into a different kind of loop today.
Right, right. We're talking about how computers learn to repeat instructions over and over.
Exactly. It's like, imagine you're driving around with a sleepy baby in the back seat. You know the drill, right?
Oh, yeah. I think every parent listening knows that feeling.
You're driving, you get to the corner, you check, is the baby asleep? And if not,
You go around the block again,
mhm,
again, hoping for a different outcome each time.
precisely. And that, my friend, is essentially what we call a while loop in programming. It keeps running a set of instructions as long as a certain condition is true, just like our sleepy baby situation.
So the loop is that repetitive action, the circling the block, waiting for something to change,
Exactly. And just like you eventually get to turn onto your street and go home once that little one is sound asleep.
which is the condition being met, right?
You got it. A while loop needs a way to eventually stop, and that's where the condition comes in. Once the baby's asleep, you can head straight home. In programming, once the condition is no longer true, the loop ends and the program can move on.
Okay, I'm following you so far, but let's bring this back to actual code for a second. How about a classic programming example?
Sure, let's say we want to write a program that adds a bunch of numbers together. We could write separate instructions for each addition, but that would be.
Incredibly tedious, to say the least,
Yeah.
especially if you're dealing with a long list of numbers.
Exactly. Loops to the rescue. Instead of writing a separate line of code for each addition, we use a loop to repeat the process for every number on the list. It's all about automation.
So it's like saying, keep adding the next number you see until I tell you to stop, instead of add this one to this one over and over again.
You've got it. And that stop signal could be anything reaching the end of the list, hitting a specific number, you name it. This ability to repeat actions efficiently, that's one of the key reasons loops are so fundamental to programming. They save time, reduce errors, and make our code much more, well,
Elegant.
exactly. And what's even more elegant is how this simple concept of repeating instructions lets us do incredibly complex things. It's not just about adding numbers.
Okay, then what else can we do with these magical loops? Give me an example.
How about calculating the average of a bunch of numbers?
All right, averages. I think we're moving into slightly more challenging territory here.
Yeah, but this is where loops really shine. You see, what seems like a pretty easy calculation for us actually involves a few different steps for a computer. Add all the numbers, keep track of how many numbers there are, then divide the sum by that count.
Yeah, when you break it down like that, it does sound like a bit much.
It would be, if not for loops. Loops make it much more manageable. Think of it like this. The loop is like a dedicated worker whose only job is to grab a number, add it to the running total, and keep track of how many numbers it's seen. The loop just keeps grabbing, adding, and counting until it gets to the end of the list.
So it's like our loop has become a master organizer for our data.
I like that. And here's where things get even more interesting. Before the loop even starts working, we do something called initialization.
Initialization.
Yeah.
Sounds important. What is that?
It's a crucial step where we set the stage for our loop. Remember how we need to keep track of both the sum of the numbers and how many numbers we've added?
Right, right.
Well, before the loop starts, we create those variables, think of them like containers,
Hmm.
and we set their starting values to 0, like drawing a starting line for our calculations.
So we're basically telling the program, hey, we're going to start adding and counting stuff, so get ready.
Exactly. Otherwise, our loop would be totally lost and our average would be way off.
So it's like we're giving our loop a fresh notebook and telling it to get ready to do some math.
Exactly. Initialization is all about making sure our loop has what it needs to get the job done right. Then, once the loop is going, it takes each number, adds it to the running total in that sum container, and adds one to our count to keep track of how many numbers we've processed.
Okay, and once it hits the end of the list, it knows it's time for the final calculation, right?
Right. It divides that total sum by the final count, and there you have it, our average.
Pretty cool. We've gone from adding numbers to calculating averages, and it's all thanks to this whole loop structure. It's like we've cracked the code for getting computers to do all the heavy lifting.
I like how you put that. And as we dig a bit deeper into loops, you'll see how this idea of repeating instructions opens up a whole world of possibilities in programming. For example, let's say we have a massive data set, like thousands, even millions of data points, and we need to find one specific piece of information.
Oh, wow. That sounds like trying to find a needle in a haystack, but like digitally.
It definitely can be, But with the power of loops, especially a concept called iteration, we can handle even those gigantic data sets.
Iteration. That sounds intense.
It's just a fancy word for doing something repeatedly.
Ah, okay, so the same loop logic, but this time, instead of just adding or averaging, we're telling our loop to, like, search for something.
Exactly. Think of the loop as a digital detective, carefully looking at each piece of data in the set, one by one, and we get to tell it exactly what to look for.
So if we're trying to find, say, a specific name in a database with thousands of names, our loop becomes like a super-powered name-checking machine.
Precisely. It would go through every single name, compare it to the one we're looking for, and if it finds a match, boom, it can flag it for us or even pull out more information connected to that name.
Wow, so we've moved beyond just crunching numbers. We're using loops to dig through data and find specific things or even patterns.
Exactly. This ability to search and filter data, that's crucial for so many things. Everything from how search engines work to how you get those personalized recommendations on your favorite streaming services. Loops are the engines behind all of that.
It's like loops are the unsung heroes of the internet, quietly working behind the scenes to make sense of all the data out there.
Totally. They really are the driving force behind so much of what we take for granted in the digital world. And speaking of driving forces, let's switch gears for a sec and talk about another cool thing loops can do. Finding the maximum value in a set of data.
Okay, now that sounds interesting. So instead of adding or searching, now we're asking our loop to figure out what's the biggest, the fastest, the most popular, that kind of thing.
Exactly. Imagine you're looking at a list of high scores for your favorite video game. How does the game know which score deserves to be at the very top?
I'm guessing it's not magic. Loops
Huh?
have to be involved somehow, right?
You got it. In this case, our loop acts like a champion seeker. It starts with the first score as the initial champion.
So the first score gets to hold the top spot, at least for a little bit.
Yeah. Then our loop moves on to the next score, compares it to the current champion, and if the new score is higher, bam, we have a new champion.
So it's constantly comparing and potentially updating, always looking for a new record breaker.
Exactly. And the loop keeps doing this, comparing and updating until it gets to the very end of the list. At that point, it can confidently say, this is our champion.
And it doesn't even have to be high scores, right? We could be talking about anything like the highest temperature in a year or the tallest building in a city, even the best-selling product in an online store.
Exactly. The principle's the same. You start with an initial value, and then you use a loop to compare and update that value as you go through the data. Super elegant, super efficient, whether you're looking for the maximum or the minimum.
Elegant and efficient. Those seem to be the words of the day when we're talking about loops. Like those behind-the-scenes workers that just keep everything running smoothly.
I like that analogy. And, it's funny, we've been talking about how programmers use loops to tell computers what to do, but I think there's something interesting here about how we can apply this way of thinking, this loop-based thinking, to our own lives, too.
Okay, now hold on a second.
Yeah.
Are you saying we should all start thinking like in code?
And not exactly in code, but maybe in terms of patterns and processes. Because when you think about it, our lives are full of routines, habits, things we do over and over again, right? They work kind of like loops. We wake up, we go through our morning routine, we work, we eat, we sleep, and then we repeat day after day.
Wow. I've never thought about it like that before, but you're totally right. It's like our lives are basically just a bunch of interconnected loops, some big, some small.
Exactly. And just like with programming, some of these loops, they're super efficient. They're helpful. They free up our brains to focus on other things. But then there are those other loops, the ones that maybe aren't so helpful,
Oh, yeah. Like those negative thought patterns that can just spiral.
Mm-hmm.
Or maybe those bad habits that we just can't seem to break.
Exactly. So the question is, how do we hit that break button on those not so helpful loops in our own lives? Can we actually reprogram ourselves?
Now, that is a question I'd love the answer to. Is it really possible to, like, rewire our brains that way?
Well, it's definitely not as easy as just changing a line of code. But the interesting thing is the principles are surprisingly similar. First, you have to be aware of the loop that's running that negative thought or that bad habit, whatever it is. Once you see it, you can start to figure out what's triggering it, what's keeping it going.
So it's like debugging our own behavior. We've got to find the glitches in our own thinking.
Exactly. And once you know what those triggers are, you can start to step in, interrupt that loop, and try to introduce a new behavior, a better one. It definitely takes effort and practice, but just like a programmer debugging their code, we can actually learn to rewrite our own internal scripts.
This is blowing my mind.
Yeah.
So not only can we understand computers better by getting this whole loop concept, but we can also use it to understand our own minds and how we behave.
That's the power of knowledge, right? It can pop up in unexpected places and give us a whole new perspective. So, next time you come across a loop, whether it's in some code or maybe just in your own thoughts, take a second to think about it. It's pretty amazing how much power there is in repetition, especially when it has a purpose.
This has been an incredible deep dive into loops.
Mhm.
We've covered everything from sleepy babies to self-improvement. I'm feeling inspired to take a closer look at my own daily loops and see if there are any I can tweak for a happier, more productive me.
I love that. And remember, even small changes can make a big difference in the long run. And listeners, we want to hear from you. What are some of the everyday loops you encounter? Have you ever tried to reprogram one of your own thought patterns or habits? Share your thoughts and experiences in the comments below. Until next time.